Oh, damn. There we are. Hello. Hi. Thanks for that. Top shelf? Top shelf? There's some top shelf action. Hello, everyone. Welcome. Thank you very much for coming to this talk. Before we begin, I'd like to start how I like to start most things in life, with a joke. A terrible, terrible joke. And because we're in a very special place, Paris, there's going to be a bit of a theme to the joke. Are you ready? That's not the joke. Here we go. So bad. I'm wasting time. I need to go. Why in France, for breakfast, are you only allowed one egg? Because one egg is enough. Thank you. See you next year, makers. Anyway, right, sorry about that. Now we got that out of the way, you can see the tone that's going to be set here. Welcome to Practical ADB, to enhance your life. Ooh, that's a clickbaity title. I'm going to try and do my best to really, make the promise of that title, but we'll see how we go. Before we begin, raise your hands if you use ADB from a terminal often. Nice, cool, because otherwise I'd just have to go at this point, but that's good. All right, let's go. Who am I? I am an egotistical maniac, as you can tell by these copious, massive pictures of me. Holy crap, that's big. My name is Ben Kadel. I'm a principal platform engineer for Android at a company called Babel in Berlin. We make like a language learning app. When I'm not doing my usual Android-y day-to-day jobs, I love Git, Bash, and the terminal for some reason. I have too much free time. Also, selfish plug, this is going to happen a lot. I have my very own YouTube channel, I'm so sorry, where I do like Devi, Cody tutorials, so if you enjoy any of this nonsense, maybe check that out. My socials are on screen there, they'll be plastered throughout the deck. Please feel free to reach out to me about anything, really. So, you're probably sitting there saying, oh, I've heard it all before, ADB talks, where somebody throws 1,000 ADB commands that you didn't know existed at you and be like, good luck, see you later, have fun. I want this talk to be slightly different. I really want to focus on practical ADB, so that's meaning that you can pick it up and actually use it in your day-to-day Android development life. All the things I'm going to show you in this talk are things that I genuinely use on a regular/daily basis. And the other side of it, maybe a little bit slightly unique, I want to give you a little bit of basic terminal/bash scripting knowledge to go with it, so that combining the two, you become an Android ADB wizard. And for those of you who grew up the same time I did, you're seeing that GIF and there's a little audio track playing in your head. Sing along with me. Da, 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 da. No? Da, 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 da. Okay. Search Gandalf Europop Nod, 10-hour remix. It's brilliant. You won't want to look away. This talk is more of a I show you the door kind of talk. I am going to go deep into several topics, but there are going to be a few topics. But what I really want to do is show you what's possible and hopefully inspire you to step through that learning door and take the learning on a little bit more yourselves after you know what is possible and how you can maybe apply it. So, there's this link, the Linktree link, with all the links. It's very important. It will be plastered throughout the slides. The QR code is to the same place, I promise. And the first important thing is, the first link in that Linktree is to this slide deck itself. So don't worry about taking pictures. You can. Feel free to take pictures. I'm a very handsome model, I've been told. But you will be access to the slides at the end. Here's the agenda, super quick. First, an introduction to ADB. It's not supposed to be an introduction to session, so we're going to move really fast, but I want us all to be on the same page. Then, there's going to be 3 main big chapters that each focus on one very tiny slice of what ADB can do and how we can use that in our actual Android development life. And then, of course, there's a chapter at the end with extra bits, like miscellaneous commands that I couldn't categorize, so it wouldn't be an ADB talk without it. Okay. ADB, or Android Debug Bridge. The very first thing you need to know about ADB is that throughout the internet, there is no consensus on what the logo for ADB should be, so I used all of them. You can pick your favorite. Importantly, it lets your Android device communicate with your computer and vice versa. It lets you do a huge range of things like uploading and downloading files, shelling into your phone, screenshots and recordings, blah, 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 loads of things. You've heard it all before. It's included with the Android SDK and is inside the Platform Tools directory. So if ever you're looking for the executable, it's in there. And you can install ADB without the need for Android Studio being on your machine as well. So that's fun to know, I guess. And hopefully it's fairly obvious that Android Studio under the hood, uses ADB all over the place to talk to the device plugged into your machine. We all good? We're all together on that so far? Nice and easy, hopefully. Here's the usual suspects, and by usual suspects, I mean the boring ADB commands that you've probably seen 1,000 times over. We are not covering them. They are boring. We're going deeper. We've got to go deeper. Inception? Anyway, I get distracted by myself. We're not covering any of these basic commands. Here's another selfish plug. If you do want to learn the very basics of ADB, I have a video on my YouTube channel about it. Check it out. It's nice. And the video includes how to install ADB onto your machine and, of course, how to get your phone to talk to your computer with the developer settings. Just in case you are right at the beginning, there's a video for you there. So, ADB. You use it all the time, even if you don't realize it. I believe it's super underutilized, though, in a general Android developer day-to-day. Now, I have to say, very importantly, I'm not the authority on ADB. I'm simply an idiot with a mouth and a clicker. That's why I'm here. There are many, many more people out there that are far smarter and better versed on ADB than me. You should listen to them, not me. But they're not here. Well, some of them are. Awkward. Here's a couple of links that I recommend you really go and check out if you're interested in like the internals of ADB, some of the more complex topics in depth. The second one there is actually a video from our very own Eyal. I don't even think he's here, but he's actually, I think, a contributor to the ADB project. So check out those links. Again, links in the link tree. As the great Alice Merton once said, I'm so sorry about this, I got no roots. Thank you, one person, I appreciate that. This is a really stupid way of me saying that everything you see in this slide deck has been done on a non-rooted device. Most of the things you see could have been made 10 times easier if the device was rooted, but I like a challenge, so they're not rooted. Little fun fact, all of the physical devices that we all have that are production ready come obviously with root access disabled by default. You can, of course, root your phone, but emulators, they come with root access enabled by default. You can immediately root into an emulator if you choose to. That's kind of interesting in case you need to do something rooty. You've got an emulator. Right, finally, content. Here we go. Chapter 1, automated input flows. For each of these big main chapters, I kind of want to deliver to you like a problem statement or an issue that we might face as Android developers in our day-to-day, and then give you an idea about how ADB could solve it, just to sort of carrot and stick this whole process. So, for this chapter, the problem that we might have. Often as developers, we need to do mundane tasks that we regularly have to do as part of development. For example, logging into our apps. It might take time, multiple screens, a bit of energy, effort, wasted time, in my opinion. So here's an idea. Why don't we use ADB to create a fast, reliable script that automatically logs me in without me even needing to touch the phone on my desk? Interesting. Carrot deployed. So no touch input. Look, man, no hands. ADB can send input events to your phone. I hope you know that. Maybe you don't. If not, it can send all types of events. Taps, licks, clicks, headbutts, text. You can see them on screen, the real ones. All kinds of input events. The command looks like this, the ADB command that you put into the terminal. ADB, the most important word. Shell, we're going to come back to that in a second. And then input, because we're doing some sort of input event. And then, depending on the type of input, it depends on the words coming next. So to do a tap event, you do input tap, and then the X coordinate followed by the Y coordinate. So this here would tap at 100, 100 on the screen as though a user has used their finger. Cool. So we've seen tap. What else have we got? We've got swipe. Swipe takes a starting X and Y, a finishing X and Y, and a duration that the swipe has taken to get from the start to the finish. Swipes. This is also how we do long presses, by the way. We just don't change the end X and Y, right? We just long press. We've got text. When a text field is clicked, you can input text as though the user's popped up the keyboard and typed it in. Oh, excuse me. And we have key events as well for hard and soft keys like the home button, volume buttons, arrow keys. A list of all of the different key events that you can use here, of course, is in the link tree. But let's focus on one in particular to go back to our use case. The tap, right? I said tap 100, 100. How do we find out those coordinates that we want to click? For example, if I want to hit this submit button, it's over this shoulder, flipping hell. How do I know where to click? I could start by doing input and then 100 and 100 and see if it taps it, and then change the value slightly, and then change the value slightly, and then change the value slightly. But that sucks, that's trial and error. There's a better way, hooray. We can set something called pointer location in the developer settings. When we toggle that on, our screen changes ever so slightly, and we get this weird crosshair that follows our finger as we move it on the screen. As we move our finger, the bar at the top there, zooming in, shows us the updating X and Y of where our finger currently is. So if I move my finger over to the submit button, look at the bar and go, there's my X and Y, jot that down, I can now use it in my tap command. Okay? That's cool, but again, I don't like touching the phone in this exercise, and I had to go to the developer settings to enable the point location. There is, of course, an ADB command for that. So from the terminal, you can set this command, I won't bother reading it out, it's a bit long, to turn that pointer location setting on with 1 and off with 0. So you can just toggle it from the terminal. And then the next problem is that that command is really long. So for me, I set a nice little bash alias. If you don't know what an alias is, it's essentially like a nickname or a shorthand version for a long command. So instead of typing ADB shell settings, put the system, put blah, 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 I just type PL for pointer location and hit enter. And to turn it off, blah, 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 PL off. Nice. Saving my time. My time is precious. I need to play more video games and look up more things in the terminal with the extra time. Anyway, so we found how we can find an X and Y for a single view on screen, a single node on screen, but what happens, we want to make this a flow, right? We want to map the login flow and click one thing, and then go to the next screen, click the next thing, and then we want to type in our email. How can we do that? Well, this brings me to the crux of this entire chapter. We're going to make a script, okay? Option 1, there's a couple of options. Option 1 is the rubbish one, right? We're going to make a script, a bash script. If you don't know what bash script is, please do not worry. It's a plain text file that contains basically terminal commands, one after the other, after the other, after the other. And they just trigger in sequence, 1, 2, 3. So here you can see I've got some hard-coded X and Y values for all my taps. So I'm tapping whatever that button is there. I'm sleeping for 1, so that's like a thread.sleep. I'm waiting for 1 second. In case the screen is changing and loading a new screen, I give it a second. And then we're tapping again, tapping again, tapping again, typing in my email. And this is fine. And we can trigger it in the terminal by typing the name of our script and hitting enter. And it's okay. And it works to a point. We've got our lovely Pixel 4 phone plugged into the computer and the coordinates. Beautiful, it works like a treat every time and it's fast. Except for when it's not a Pixel 4 anymore. If we don't have the phone that we've written this script on anymore and we have some sort of ugly little thing where all the resolution or density is different, the location, the hard-coded X and Ys of my previous button are no longer the same place on that other screen, and of course my login script fails. Boo. So, I bring you to option 2. UI Automator. UI Automator is another tool available to us. It's actually used for UI testing, but we won't get into that. For us, we can use its power to query what we're seeing on the screen. So this command, ADB shell UI Automator dump, as it is there, will capture a snapshot of the current screen as you see it and dump all of the nodes out into XML for you. So all of the things you see on screen get dumped out into XML. So for example, over this shoulder, the maybe later button in gray, obviously this is highly concatenated because this is absolutely huge, there's loads of nodes, but I found a node that contains the text maybe later. Well, that's my button there, interesting. And what's that next to it? Well, that's bounds. We're going to come back to that in a second. So we get this XML dump, and once we've got this XML dump, we can use programs like grep, cut, and sed to sort of take all of that big long string, search through it, the piece of string we're interested in, like maybe later, find that node, and then find the bounds associated with that node. And this is just rectangle bounds. Hopefully you're all familiar with rectangles. I don't know. Sorry, that was a little condescending. Familiar with rectangles. From left to right, we have the top left corners X, top left corners Y, the width of the rectangle, and the height of the rectangle. That's cool. On screen, in pixels. So with a little bit of maths, we can find the dead center of that rectangle, and we've got an X and a Y, which we can then put into the tap function. Awesome. So no longer do we need to have hard-coded X and Y values. We can use UI Automator to find it responsively. If the screen changes, whatever, we can find it responsively. That's not the right word I'm using, but you get the gist. Little side note. When we do the command ADB shell UI Automator dump, the one I just showed you, that dumps the XML, by default, it takes the XML and dumps it into a file on the device, on the phone, which is fine, but we're likely going to be running the script off of our host machine, our laptop. So we need to take that dump and bring it over to here so that we can parse it, search for the string, do the bounds, rectangles, etc. So we need an extra step. We could do ADB pull afterwards and pull the file that was just dumped onto our host machine, but that's 2 commands instead of 1. There's a better way to do it, of course, with everything. This command, totally copy and pastable, the highlight green one. ADB, exec out now, instead of shell. I'm going to put another little mental asterisk here. We're going to come and explain exec out a little bit later. But this command, exec out, UI Automator dump dev tty, instead of dumping the XML onto the phone, where you have to pull it, it dumps it straight back to you, into your face, on the terminal. Cool. And below it is how you might use that in a bash script. You capture the output in this variable called output. We'll talk more about implementation in a second. Please don't let me scare you away. Okay, back to option 2. So we get rid of all of our hard-coded values, and we now write a bash script called, a bash function called get coords. Wow, the laser can reach all the way up there. That's cool. Called get coords. We pass get coords a single string, like remind me, or maybe later, for the node that we're trying to find. Behind the scenes, get coords does the dump, UI Automator dump. It does the parsing, finding the string that we're interested in. It then looks for the rect, the bounds, does the little maths, and spits out coordinates for us there that we can put straight into tap. And that works, right? That works. Again, we use it, we trigger it with login.sh, and it's much better, it's responsive. When we change the phone, everything doesn't come crashing down. There's just one more problem now. UI Automator dump is slow as hell. It's really slow. Like, I'm being over dramatic, it's not slow as hell. Each dump takes about 2 or 3 seconds, right? But when you have a flow where you have to dump every time the UI changes, so click that button, dump. Click that button, dump. Click that button, dump. Adding all of that time up makes your script no fun to run and slow and annoying. So, of course, I gift you option number 3, the best option. I'd like to introduce you to a UI Automator 2, which actually has nothing to do with Android or the SDK. It's actually just a sexy Python wrapper for the vanilla UI Automator dump. It just does some clever footwork to make the responses pretty much instant, like rapid, right? You can install this package using pip onto your machine. And then back in our bash function, get coords, wherever we used the vanilla UI Automator dump, we now replace it with this completely copy and pastable Python snippet, okay? Where you, instead of calling UI Automator dump the vanilla version, you call UI Automator 2 dump instead, and it's rapid. Now, I've talked a lot of theory. I've not shown you any code at all. I could throw it up on the screen, on this massive, massive screen, but that would just be a waste of your time. So instead, I'd like to point you to the link tree where there is a gist of this exact function that you can copy and paste into your own scripts. I think I didn't call it get coords. I think it called tap if exists or something like that. But anyway, in the gist is the actual implementation for that, just so we save everybody's time. And it looks like this when we're done. There's the start of the GIF. Going from logged in, I'm not touching anything. It's just sitting on my desk, and it's not sped up at all. It's fast, it's rapid, and it's doing all of my input, password, username for me. Cool. But there's one little extra bit I want to give you, because there's still one problem, in my opinion. We've had to open the terminal and type login and hit enter. That's a lot of steps. Of course it works, but we can do better. What if we could set a keyboard shortcut or a nasty little icon on the disgusting touch bars on some Macs to trigger the login for us? Of course we can, using a tool called Automator, not confused with UI Automator. If you have a Mac machine, Automator is already installed. If you're a Windows user, I apologize for the next minute. Here on the slides, again, I just want you to go to the slides or take a photo of this now because the next 2 slides show you how to set that up. The first bit, I'll just explain it and you can come back to this later. We need to use Automator to set up what's called a service on our Mac. Once we've got a service there, we can trigger it from all sorts of different places, right? We do this, we open Automator, quick action, Apple script, and we change the script bit here to point to your absolute path for your login script. Then we've got a service. Next, if we're setting up a keyboard shortcut, we go to System Preferences, Keyboard, Keyboard Shortcut, Services, because we're triggering a service. And then this is the bit that caught me out. Our services live under the General tab for some reason, so just keep that in mind. But you can see I've got a couple of services there. And there's my login one, and then I can set whatever keyboard shortcut I like, so that my flow now looks like this. When I'm ready to log in, I don't open anything else. I hit Function Shift F10, and next to me my phone goes, oh, goodness. My phone destroys everything. Please, I haven't got the time for this. Okay, good. Yes, and it's delicious. And there we have a fast, reliable login flow, for example. But hopefully it inspires you to maybe think about your boring automated flows that you could make automated. Cool, that's chapter 1. That was the long one. We're now going to have shorter and quicker, okay? So stay up with me because we've still got a couple of minutes. Domsis, get all the infos, is the next chapter. The problem statement here would be something like, often we can't be exactly sure what is really happening behind the scenes on our phone, right? We think we know because we wrote the code and we triggered some functions, but is it? I think I set an alarm with Alarm Manager, but it didn't go off. Did I actually set an alarm? Or I think I inflated a fragment on screen, but I'm not seeing anything. Am I looking at the fragment? Am I not? So, the idea is use a tool called Domsis, which is absolutely insane and amazing, to quickly get information about all manner of things on our device, all manner of things. But in this one, we're going to focus on specifically information about a running app. Let me tell you more. And I said, hey, what's going on? Anyone, raise your hand if you know what I'm doing there. Oh, thank goodness, okay. And the rest of you are like, what the fuck am I gonna get out of here quick, he's gonna kill us. Okay, it's a weird way of me introducing Domsis. I couldn't think of anything else. Domsis is a tool that's essentially a diagnostic output for all system services on the device. Now, that is a huge ballpark to play in. It's incredibly useful and tells you everything, but what's important is it really tells you what's happening in your phone, the truth of it all, without having to guess. Tells you all sorts of things about running activities and fragments, battery, alarms that are set, package information, and so on and so on. Here's the command. ADB, shell again, Domsis, and then the service that we'd like to query. For example, I want to find out all the alarms that are set on the phone. Domsis alarm. It tells me all the alarms that are set, which package set them, and the pending intents that trigger when it's time to go. We've got battery. Is it charging? The percentage. We've got information about apps installed, packages installed on the phone. We pass it, of course, a package ID, and it tells us loads of things like version numbers, permissions. We've got job scheduler. If you're doing anything with like background work, like with Work Manager, this is amazing. You'll see if your work is actually scheduled and for what constraints. But the one I want to focus on is Domsis activity, and you pass it a package ID of an app that's running on your device. It tells us information about that app, things like the task is encapsulated in, the activities that are active and running, the fragments that are active and running, the fragment transactions that have happened, a dump of the view hierarchy. You know, like the XML, the text view, here's a text view, here's a text view. The dump, the view states, if an activity is paused, started, resumed, the object references, so I can tell if that fragment is the same one I've seen before or if it got recreated for some reason, and loads more. The problem is the output is ridiculously big. This is just a slice. Like, this is like the first 3 scrolls, and I was like, I can't do any more. This will I have to do. It's massive. So in a pinch, in a quick, you can't get the information without having a little bit of effort involved. So I want to do 2 things. One, I want to give you a quick 101 of how to kind of read that output, the structure that it comes in, and then I want to give you one better. So this is the structure, roughly, when you get the output. First of all, we have the task, and then underneath it, please note all of the indentation. The indentation showcases parent-child relationships. So these activity blocks belong to the task, and so on. Inside the activity block, we get a view hierarchy dump of the activity. Any fragments that are in the activity with their fragment managers, child fragment managers, and any fragments all the way down to the bottom pits of hell. And then, of course, we get the backstack with fragment transactions. That's the rough, super quick version. There's loads more information that I've skipped there, but that's a rough idea of how to read it. Indentations are king in here to help you with that. Cool, but I said I was going to give you one better. There's a tool called EasyDumps, which is essentially a glorified Domsis activity parser. It takes all of this big, disgusting output and quickly turns it into this bottom screenshot at the bottom with just distilled information and things that are, for me at least, things that I was interested in knowing. For example, which activities am I seeing? Is that the active one? The fragments that exist in that activity, the hierarchy of the fragments. Are these fragments active? Am I seeing them on screen with their object references? Loads of information. For me, it's a really useful tool. I do a lot of code challenge reviews for hiring. And for me, when I start an app up, I can run EasyDumps and immediately get an idea of what the hell am I looking at, right? The second one is for diagnosing during actual development work. If I see a fragment and it's blank on the screen, I can immediately go, well, is that the fragment I'm seeing? Domsis, oh yeah, it is the today fragment. I've screwed up something on my side, right? And so on. The final bit I want to point you to on this slide is these 3 letters here, FZF. Oh, FZF. I'm going to put another asterisk here. We're going to come back to FZF later because I want to explain it. But just as a sort of quickie, FZF is built into EasyDumps, and you'll see why later that's so useful. Okay, but if you hate me or hate things that save your time and tools, then I want to show you how you can quickly search through the output of Domsis yourself using something like grep. You call the command Domsis, and you pipe it into grep. Grep is basically a string searcher. You have one big input of string, and you say, hey, I'm looking for the words hello world. Is it in there somewhere? And grep will be like, yep, here it is, or like, no, it's not. So you can use grep. We can search the Domsis output for the word activity and find out what activities we're seeing really kind of quickly. Or we could search for bottom navigation item view to see the bottom nav items that are there in the dump hierarchy for some reason. But there's one little extra gift I want to give you here. And it's with grep, you can append one of 3 letters to the command. They do different things and give you different output based on the letter. -A with a number behind it, for example 3, will say, hey, grep, search for this string activity, but make sure you give me the 3 lines beneath the line that you find as well. B means before, so if you use B and a number, it will give you the lines before the searched found line, and C is around, or both A and B, both above and below. Now, why is this useful? Well, if you're using the activity search here, in the output of Domsis, you will find activities, but the activity state is not in that same line. It's actually 2 or 3 lines beneath it. So if you do, hey, tell me about the activities, but you want to know their state as well, -A for the next 2 lines as well will include that information for you quickly. Okay? Just a little something extra. Anyway, ladies and gentlemen, it's very important. Now we have a quick selfie break. So I always forget to do this, so I thought I'd just build it straight into the slideshow. I'm dead sorry about that, but hey, there we go. If you don't want to be in it, hide your face, or turn around, or just leave, or whatever. Ready? Oh, the time's in, you can see it. Ready? 3, 2, 1, smile. Okay, cool. That was the quick selfie break, brought to you by Budweiser. Back to work now, please. Goodness. Rabble. 3rd chapter. What does your app know? Here's the problem statement. We can't exactly be sure about the actual local data that's stored on our device. Like, again, we think we know, but we can't be sure. And to check it, it's not really easy. There's some tools for us, but to check things like shared preference values, we maybe have to make a code change or breakpoints or whatever. So here's the idea. Use ADB to let us quickly see and alter information locally stored on the device. For example, shared preferences. For example, if you have like a feature flag in the shared preferences, you want to see it, quickly toggle it, see the results. Ooh, interesting. So let's dive in. As I said, we store loads of things in our app's local storage. To find that information, we set breakpoints or print lines when the data or information is transacted, so we can sort of get in the middle. But that check, the ability to sort of go, oh, is the information formatted right, or what is the information? It's not quick at all. It often takes a bit of time, a rebuild, a bit of code, whatever. The information, by the way, just to be clear, 3 examples of things. Shared preferences, like I've said, file contents, if you write files to your app storage, or database contents, like room database contents. So that's the kind of data I'm talking about, things that are locally on the device. Now, in order to get to that information, we need to get into our phone. We need to get into the heart of this thing, right? And to do that, I need to introduce you to ADB shell. ADB shell, when triggered like this, essentially acts as though I've left my computer, bye-bye, and stepped into the phone, and I'm now running commands and stuff as though I'm inside the phone. You people are far cleverer than I am. If it helps, it's like you've SSH'd into the phone, okay? You can see in the GIF, I've left my sort of normal prompt, and I now have a weird prompt, and I can run commands in the phone, right? We've talked about shell a lot, but always in correlation with another command at the end. And the difference is, with a command at the end, it doesn't give you this lingering interactive terminal session, like the normal one does. Instead, it runs said command, as though it was in that terminal session, exits, gives you the output, and it's done. So it's like, go, and shell is like, lingers. I don't know what that was. Too much coffee. Okay, let's keep moving. Now, I'm going to pluck one of those mental asterisks out the air for the exec out bit. Remember we said we'd come back to that. Because ADB shell and ADB exec out seem very similar, but there's a very key difference. Remember we had that command, UI Automator dump with exec out? What's that mean? Let's understand it. We've got a phone plugged into a computer. When I run ADB shell, UI Automator dump, please note that the dump function here takes a file name, and I've just called it file, right? Takes a file name, and it will store in the file with that file name, okay? So with shell, the file gets stored on the device, like we've seen. That sucks. But with exec out, the exact same thing, but exec out is the word instead. The file gets stored on our local device. Interesting. Because you can think of exec out as though it's done a shelly command, but then it picks up the output and it sort of moves it into the context of our local machine and sort of throws it back out there. So when we're saying store in a file here, it means store in a file on our local machine. So that's the difference. Exec it out, and shell is like stay in our little sort of domain. So hopefully this makes a little bit more sense now. And the dev.tty is a Linux Unixy thing, where if ever you write to that file, dev.tty, it will write the output straight to you back in your terminal session, like right to you on your screen. You can try it. If you ever just like echo into that file, you'll just see it come straight back out to you like you've echoed. Cool. Right, back to what we're trying to do, get our app's internal data. So we can get it to the phone. ADB shell into the phone, and our prompt has changed. And somehow I know, that app's internal data is stored in the /data folder. So what I'm going to do, I'm going to cd into the data folder, I'm going to ls to see all the files and folders, and oh, permission denied. Okay, no worries. Don't ask me how I know this, but I know the entire absolute path for my app's internal storage folder. I just know it. So we're going to cd straight into there, and we're going to get, oh, permission denied again. Okay. This is a good thing. It would be an awful world that we live in if anybody or anyone could just look at your app's internal storage, look at it, read it, and write it. That would be a dreadful, dreadful security hazard. So there's a way around this. A command called runAs. Whilst we're shelled into the phone, we can use runAs followed by, now this is really important, followed by the package ID of our debuggable app, okay? And that basically says to the phone, hey, pretend I'm the app for a second. Let me just see the world through the app's eyes a little bit, okay? You'll become the app. You'll be immediately CD'd into the app's internal storage area. Your user will change. You'll become a different user altogether, and you can now ls the contents of the files and folders. Brilliant. And look, there's our app's internal storage. Ooh, there it is. There's the folders that we're seeing. Hopefully some of them are semi-familiar. Each of these folders, like shared preferences or files, actually in our code, in like Kotlin world when you're writing apps, has an API for it. So in the context object, we can do context.getFilesDir, for example, and it will return us the path to that folder right there. Or we could do getSharedPreferences folder, and it'll give us a path to that one right there. Okay? So we can access those places in code without extra permissions, because it's our app internal storage. And we can write to that. And if I write this file called file.txt, and then look inside this folder, guess what I'll find? A file called file.txt. Yay. Cool. So let's take our example now, back to shared preferences. So we found out how we can find our data. Let's look at it. Inside the shared preference folder, shared preferences are stored in XML files. So whilst we are running as our app, I can cat out the contents of these XML files. And cat is just like, dump the output of the file to me, please. And we get this. I'm seeing the shared preferences in the file. They're key value pairs, email Ben at Ben, or I'm seeing last login, some timestamp. Cool, we're seeing it, but we can also alter these values now, and this is where the real interesting power comes. So let's edit some shared preferences. To start with, the very unfortunate news I have to give you is that in an unrooted device, we don't have access to a text editor, like Vim, Vine, Nano, Ed, if you're a disgusting monster, Emacs. None of those are available to us. And the other problem, I've just offended a lot of people, I'm sorry. And the other problem is we can't just pull the shared preference file down, edit it and push it back up because we haven't got the permissions to do that, as we've seen. But with a sneaky combination of runAs and a program called sed, we can do that. Sed, by the way, is just a stream editor. It's probably installed on all of your machines in this room. It's wonderful. I'd recommend learning more about it. But it's very basic usage. It takes one type of input, a big string. It runs some manipulation on it as a sed program and then spits out the output saying, hey, this is how it would look if you made those changes. So for example, it's like, hello world, change all of the E's to A's. It's not very good at, and then it's like, okay, hello world. Yeah, there we go. A little bit of German for you there, although the world was wrong. Anyway, ignore me. Again, links in the link tree if you want to learn more about sed. By default, as I said, by default, sed doesn't make the changes to the incoming stream. It doesn't overwrite, for example, the file that we give it. It just says, here's the output, this is how it would look if you were to change it, except for there's a sneaky flag, -i, or for in place. This basically tells sed, hey, yeah, go ahead, overwrite the file. I'm crazy. Overwrite the file, do it, right? So with this sed program, whilst we are shelled in, whilst we're running as our app, we can use sed because it's accessible on our phone or device. We can use sed -i to say overwrite, give it our shared preference file here, and then run a little sed program, this thing in the middle. I'm not going to go into sed programs. I'd recommend looking into it because it's really, really useful. But this one basically says replace every instance of Ben with Tim. So the email would become tim@tim.com, and I've changed the email there, right? It's a little bit bumpy and bulky, a bit gross to use, and there's also another problem there. What if Ben was somewhere else in the shared preferences, or what if I destroy my shared preference file accidentally with a sed program? So, again, I'd like to give you some things to look at. Feel free to use these or just look at them to see how the implementation of run as with a combination of sed helps. The top one is a repository called prefedit. It basically, inside the terminal, gives you an interactive shared preference editor where it's like, hey, here's your shared preferences. You want to change one? You're like, yeah, change that one. It's like, what new value? Okay, new value. And it does all the run as and sed for you. Or there's the other one beneath it, which is the one I prefer. This gist here pulls down the shared preference file to your computer, lets you edit it to your heart's content in your favorite text editor, which of course is Vim. And then it does all of the clever uploading for you with a little bit of fancy sed footwork. Okay, again, links in the link tree. Please check them out. Oh my goodness, I'm running out of time. But the last bit here is other information stored locally on the device, like SQL databases, right? We have those. Hopefully you're aware, I'll just say this outright, that Android Studio has a database inspector where you can file things. So this is essentially useless. But just in case you're crazy, like me, you can't cat out a database on the device because it would just be nonsense gobbledygook that is hard to read. But we could use a command, and with a bit of combination of execout, a clever combination of execout and run as, we can dump the output of a database file onto our host machine into a file called out.db in this instance, and then when that file's on our machine, we can just use an SQL viewer or a database viewer to look at the database. Like SQLite 3, for example, I pass it my file, and it will inflate a prompt for me as though I'm looking at a real database and firing queries at it. So I can say, hey, what tables are in this database? It's like, oh, yeah, you've got users. And then I can say, oh, SQL query, show me all the users. And it's like, here's all the users. And then you're just limited by the SQL knowledge that you have. But you can, of course, query the databases a much easier way in Android Studio. Fun fact, SQLite 3 is actually packaged as well with the Android SDK in the same folder that ADB is in, the platform tools. If you look in there, you'll find a program called SQLite 3, so you don't need to install anything extra to do this. Again, links in the link tree. Oh, goodness, everyone all right? All right, we've done it. We did the 3 big chapters. I hope that was somewhat insightful. Now we're going into the weird realms, the little extra bits. I've got 4 little extra bits that should take 2 minutes max each, and it should be perfect timing. So let's get into it. Number 1, I've come back to FZF. There's the other little asterisk. Get out of here. FZF is amazing. Even outside of Android, I'd recommend really looking to FZF. It's a command line fuzzy finder. What the hell does that mean, Ben? Well, here's a very basic example. We can pass any multi-line string to FZF. We can pass it multi-line string. FZF will take it, break each line down into its own option, and then give us an interactive menu to select one of those options. Here, I give it cat, new line hat, new line bat. I pipe that into FZF, and it does this. In the bottom left corner of my terminal, I've got this interactive menu. I can use the arrow keys to select one of the options, up and down, or I can start typing, like autocomplete or fuzzy finding. I can type C, and it will eliminate all of the options that do not contain C, so I can quickly narrow down my selection. When I hit enter on the selected option, the output of the FZF command here is that option. I can then do with it what I want. We'll see some examples in a second, but I can do with it what I want. Again, selfish plug, I'm so sorry about this. I have a video on FZF on my channel. If you want a real introduction, deep dive, check that out. It's real stupid. But take that FZF information and apply it to Android. Anywhere where there's a list of things, and we need to select one of those things, we can use FZF to make our workflow better. For example, multiple devices plugged in. ADB's like, oh, I don't know which device you're talking about. Ooh, I'm going to cry. Plug FZF into that stream, and no longer is ADB upset because you've had to select which device you're talking about. This code is copy and pasteable. It runs the devices command, removes the top line, any blank lines, pipes it into FZF, makes you choose which device. Cool. What other terrible examples have I got for you? Packages on the phone. We can use PM, Package Manager, list out the third-party apps that are stored on a device, pipe that list into FZF, do with it whatever we want. Maybe put it into our system clipboard and use it somewhere else in the terminal, right? Anywhere there's a list, FZF. Cool, there's my plug. I get commission from F to F. No, I wish I did. Next one, screen size manipulation. We're almost there. Stay with me. This is a bit of a weird one. If we use ADB shell WM for window manager and size, by default, it will print out the current physical size resolution of our screen. Okay. What if I add a number, a new resolution to the end of that command, 480 by 800? Exact same command, I've just added a new resolution. It actually physically changes my screen in front of me on my device or on my emulator. It's changed. Everything's got smaller and doesn't fit. The icons have grown. It's weird, okay? Different resolution. I've got density as well. Without a number, it just reports, yes, you're using 440 dpi. With a number, it changes the density of the screen as well. Okay, but please don't panic. We can use WM reset to take it all the way back to 1, in this case, how the phone was supposed to be. And why am I showing you this? Well, if you want to test your app quickly on a device that you don't have access to, and, importantly, you can't be bothered setting up an emulator, right, because that's the kicker, you could quickly look on the internet, oh, Pixel 2, it's this resolution by this DPI, set that up, and immediately you have what a Pixel 2 would look like with your app. Just a little something. I don't know, maybe not useful. The next one is called Start Your App Without Knowing the Activity. Now, this is really bespoke. I use this all the time. Maybe there's one or two of you that's like, oh, I'd love to know how to do this, so let's just try it out. ADB shell AM for Activity Manager and Start. This is how we start, normally, an app and the activity of an app onto the screen. -M is the component, and a component takes a package ID of our app / a class reference for the activity that we want to start. And that's fine, that works, if you know all of those pieces of information. But what if we don't know the activity? Because maybe we're not the original author of this app. We can't just pass package, because this will complain. It says, I don't know how to resolve the intent. So, to the rescue is a very peculiar tool called ADB Monkey. Right? Monkey is an application stress testing tool, usually. We'll come back to that in a second. But Monkey, we can use Monkey instead of Activity Manager Start to do this use case. With ADB shell Monkey, -P for the package we want to start, and 1 for the events, the number of events we want to send. We just want 1, just open it, and I'm done. And that will trigger the app without me needing to know anything about the activity. Whilst we're here, let me talk about Monkey super quickly. Application stress testing tool, like I said. It's as though you've passed your app to a monkey, and they're just going, like mashing input at 1,000 frames per second or whatever, all kinds of crazy input that you'd never expect your users to do, and you get to see if your app can withstand the barrage. It's quite interesting. Or if your app falls over, and why. So here's an example command. At the end, you can see the number 5,000. I've said, Monkey, do 5,000 random crazy events for me, and let's see if my app can withstand it. I've passed -F for seed, so it's a random seed value, so that I can recreate the exact same sequence of Monkey actions again. Just in case this barrage does destroy my app, I can try and fix it, and then run Monkey on it again the same, and see if I fixed it. It's kind of cool. It's just interesting to see if your app can withstand it. And the final one, we're getting there. The final one, I'm almost done, I promise, is permission testing. It's not really permission testing, it's messing with permissions from the terminal. We often have apps like this that have runtime permissions, where it's like, hey, are we okay to post notifications? Allow or disallow, right? And we usually, the user says allow or disallow. But we can do all of this from the terminal without even opening the app. We can grant the permission. We can say, yes, allow, from the terminal with PM, package manager grant. We pass it the package, and then the full name of the permission. So in this case, it would be android.permission.postNotifications. And that would say, yes, allow. We could revoke, which is disallow. No, I don't like that. And then the most important one, in my opinion, which is clean up any existing answers that have been given before. So this is like the user's never been asked the question, so that hopefully you can test your app again and see that same dialogue. And if not, something interesting is going on. So that's just maybe a little interesting. Oh, we're there, ladies and gentlemen. Thank you so much for listening. I've got a little amount of time left. There was so much more I wanted to talk about, so here's just a couple of honorable mentions that I wish I could have put into here. Some great tools, some great GitHub repositories. All of them are included at the bottom of the link tree. Things like Screen Copy, which is mirroring your device to your computer for presentations or whatever you want. Some GUI, some disgusting GUI ADB tools if you want to use a GUI. No, I shouldn't be so judgy. Integrations with IDEA, IDEs, really, really great things. Please check them out. One last thing, I do have an office hours happening right now, like right after this talk. So if you want to ask me some questions or have a more intimate one-to-one session, sounded really weird, I'm sorry. An intimate session, then please come find me on the first floor somewhere. I'll be somewhere. And that's happening now. And that has been it. Thank you so much for your patience and for listening. There's my socials. I do have Because I'm so big-headed and egotistical, I do have stickers of my brand. So if you come to the office hours, I'll try and give you a big sticker or a small sticker of my ugly mug. And of course, right at the bottom is the all-important link tree. I cannot state enough like how much you'll get more out of that than you did out of this idiot. Okay? Thank you so much for listening. Any questions? 20 seconds on the clock.